Right, now that's enough of my storytelling, but just want you to know what happened as a result of what I did on this class last week. Right, so internet.
And I wasn't even there.
And you weren't even there, Kyle. I know, tragedy. Okay, we watched the recording though. I thought it was fun. All right, so the internet. So how much do you all know about the internet? Okay, so now let me, like I said, we'll be doing practical stuff, but I want to show you some diagrams first to set the context here from the old slides I used when I used to teach this thing at the dojo itself, when we were fortunate enough to be there. Okay, so you all know, you're as we said, you're all using the internet right now to talk to me. You can see me over the webcam, you can hear my voice, you can chat to me, you can play games online, you can browse web pages and watch videos, etc. These are all applications of the internet, something you can use the internet for. But what is the internet actually?
You can look up Linux Ubuntu ISOs while trying his best to listen to what's going on
I see
elsewhere on
exactly.
his computer.
So for two computers to be able to talk to each other, they have to be connected to each other. And when two computers are connected to, or two or more computers are connected to each other, that's what we call, they're communicating over what we call a computer network. It's a network of computers, okay? And the internet we all know and love, for among many reasons what Kyle just said, is the most well-known computer network in the world.
I have a love-hate relationship with it.
Don't we all? Right?
Like, it's just Linux Ubuntu ISO is like 10 gigs. If I randomly disconnect, you know why.
Of course, I understand how that's.
By the way, I'm running this off of a janky Wi-Fi box that was installed about 4 days ago
Well, good luck with
in
that.
Friliana, Spain.
Oh, nice, very nice. Well, maybe when we're finished here now, we'll understand why you cut out if there's a problem there, right? So the internet.
Because I'm in a middle of nowhere village in the middle of nowhere in the middle of nowhere in Spain.
Oh, you're in Spain.
Luckily, yeah, we managed to get a flight. My parents got vaccinated, and I had to get something shoved up my nose.
Oh, it's okay. Well, the internet is the largest computer network. We're all talking to each other over the internet, okay? And your internet service provider, which is probably something like Aircom or Virgin Media or Vodafone or something like that, provides internet to your home using something like fiber optic broadband or DSL-based broadband, okay? So we use these things to communicate with one another. Now, what I want to show now, that's the context, right? But what I want to show you is this diagram. And before we look into some of the applications in the internet tonight and do some programming, what I want all of you to understand is your place within it. So where are you? So this is one of my favorite diagrams from back when I was a student. It was called the pieces of the internet. So where do you sit here? If I zoom in on this diagram, right?
You can tell by the look of those laptops that it is about like many years old.
For sure. Now look at your home.
There's an antenna on them.
I know, yeah. Now look at your home. Look at your home network here. Okay, so in your house, you have the house symbol here, right? You can have many different devices, and I'm sure in your houses now where you are, you might have several different devices as well. So you might have a desktop computer, which might be connected to the internet via a cable, so an Ethernet cable. Maybe I should have brought one here, but anyway.
If you have a desktop, and you can use Ethernet but choose to use Wi-Fi, you are a monster.
You are. And you have the laptop over here as well. And the reason of the antenna, as Carl points out, is just to identify that device there is connected via Wi-Fi to the internet.
Also, this diagram is really old. We can't forget that part.
It's not connected via cable. Okay. So in the home, you might obviously have more than desktop computers and laptops, right? You can have things like PlayStations or Xboxes, mobile phones, iPads. They'll probably all connect via a Wi-Fi connection. And what you're probably going to have here, as Carl said, this is a very old diagram, right? And you'll see why in a second. What you can see here on this bottom left-hand side is this is essentially the modern day equivalent of your router, or your router, I should say. You all probably have
modern day.
A box that you have from your internet service provider where all the internet in your house comes from. So that will be supplied to you by your internet service provider like Aircom or Virgin Media or whatever. It emits the wireless signals, and if you are connected via an Ethernet cable, it's probably plugged into this box. But this little diagram, I beg your pardon, this component here, the circular component, is what's known as a switch. So you might extend your whole network with a switch. The switch plugs in to your router. Okay, and that just allows for more, they're normally for connecting more cables. Your switch connects to the router, and you could actually, I have a switch over there, but I won't get up now. So you could plug a switch into your Wi-Fi router or into your router, and that would allow more cables to be connected to it. But then at the very edge of the house here, and you can see there's a line coming out of the house. This is a bit of an old-fashioned term these days, right? This is your modem. A modem is what's actually used to establish a connection to your internet service provider from your house. These days, your router, I keep sounding American, your router has the modem built into it. Okay, so this device here, the actual router with the antenna and the modem, that's one device. Okay, and you're either connected to them via cable or you're connected to them via a Wi-Fi. Okay, and it is that modem that actually talks out, and you can see the little line there, and it's going across over to your internet service provider. We don't really care about what's going on there at the moment, but it talks to your internet service provider. And your internet service provider, again, Virgin Media, Aircom, Vodafone, whatever, is connected on its own back network to all sorts of other internet service providers around the world. And this is how my computer here in Cork can reach out and talk to Kyle's computer in Spain. There's a good example. What fortunate timing, Kyle, right? That I'll connect to my local internet service
I
provider.
can barely hear you as I'm downloading the Windows ISO, but I heard my name and I heard what was affiliated with my name, and I just wanted to say something. But now that I'm saying something, I realize I have no idea what I wanted to say.
Oh, look, don't worry about it. I'm just complimenting that you're in Spain, and my ISP, my internet service provider, Virgin Media, can talk to the internet service provider that whatever your apartment or house has.
Let's call it jankybox.es.
Right. So that is an ISP, presumably, and my ISP can talk to Kyle's ISP. That's how we can communicate over long distance, and of course, here in Cork as well, where all of you are as well. Offices or institutions often have their own big networks as well, lots of switches, maybe multiple routers.
I'm looking at Task Manager, and I actually think my computer might be committing suicide. I'm not entirely certain, but like 100% all cores is a bit of a problem.
Well, fairly well if we lose you, Kyle. You also have the mobile network, so that you've got mobile devices up there, and via a cellular base station, the signal bars on your mobile device, that's also talking to an ISP somewhere. So lots of different bits and pieces of the internet, lots of devices, and in some way, they're all interconnected with each other, right? So that's what I just want you to understand before we look at before you'll be looking at some of the things I want to show you tonight. Does anybody have any questions about that before we move on about where they sit or how devices talk to each other?
I would just like to give some good news. CPU utilization is no longer killing itself. It is down to roughly 25%, which on an 8th gen mobile Core i5 from like 2017 is an absolute miracle.
Well, that's good. Yeah. No, not
especially considering I'm downloading multiple files plus this.
Well, that's very good. But let's keep the discussion relevant. There'll be a lot to get through, okay, in the next hour. So, any questions about this diagram, guys, or where you sit in it? Very good. Okay, so that's the diagram, and that's the diagram. Okay, so let's go back to the diagram. Let's zoom in on my home. Let me zoom in on my home. So I'm on my laptop at the moment. Whoops. Whatever. So I'm on my laptop at the moment, so I could be this device here, and I'm sure most of you are connected on laptops as well. So actually, at this point, I would like someone else to take over from me. It's enough diagramming for now. Not you, Kyle, because you're obviously. Oh, there we go. There we have it. We have it. Okay. Oh yeah, that's very cool. Okay, that's great, Connor. Okay, so Connor, if you go to your start menu there, right? And if you type in CM, yeah, thank you. Okay, no. How did you know? Okay.
There.
Right, excellent. Okay, so Connor, I'm assuming you're on a laptop, are you?
Yeah.
Yeah. Okay, cool. So no worries. Okay, so hands up if now you stay there, Connor, because you're gonna do this stuff for me now. But let me ask a question to everyone else. Has anybody heard of an IP address? And if they know what it is, would they like to put their hands up and tell everybody what an IP address is? If they have any idea what it might be. No, has nobody heard of an IP address? Oh, thank God. Ian, okay.
It's kind of like a digital address. You can like, yeah, digital address would be my description.
That's a very good description, actually. Like a digital address. Okay. So every computer connected to a network has to have an address. It's like if I wanted to post, if I wanted to post a letter to Caleb's house, if I want to post a birthday card to Caleb in next January, spoiler alert for everybody. If I want to post the birthday card, I need to know the address of Caleb's house. Okay, and if Caleb wants to send me a thank you card, he needs to know the address of my house, right? So we need to have some way of addressing each other, and the means by which we do that is by this like digital address that Ian mentioned, an IP address. IP, by the way, stands for Internet Protocol, right? And it's the primary way that devices over a computer network talk to each other. So Connor, my friend, your laptop on your Wi-Fi network there must have an IP address. Now, there's a way to see that on Windows, and what I want you to do, Connor, is if you type in ipconfig, just one word, ipconfig, and it's one word, Connor, no spaces. And if you're sitting at home, obviously watching this, please feel free to follow along these same commands, right? So ipconfig, let's have a look at that. So if you press enter now, Connor. It's running. It's just okay. So there we go. So there we go. And actually, so you've several different network adapters in your computer, Connor, right? For example, you probably have an Ethernet port in your computer, which is probably disconnected right now. So you can say that Ethernet adapter 3, which is media disconnected and whatnot. But the one at the bottom is probably what we're interested in right now. It says wireless LAN adapter Wi-Fi. And do you want to read out your IPv4 address there for us, Connor? Let the meeting know.
Don't DOS me.
I'm not going to DOS you. Well, I wouldn't be able to DOS you. That's part of the discussion here. You might not realize. So what's your address, Connor?
192.168.4320.
Okay, cool. Okay. That's very interesting. So that's your address. Okay. Now, Connor, another little experiment for you. Why don't you can you open Google there, for example? Open up your web browser in Google.
Yeah. Might take a while because like 6 things open.
That's okay. You should try uninstalling some of those games. Right. If you right, so you've got your Google search there on the bar, right? So why don't you type in what is my IP?
I'm trying.
That's okay. Okay. Right. Run that first when you're ready. This is a cool feature of Google, people. It's not the only way, but it will tell you your IP address when Connor's laptop is ready to make that request.
Yeah. This is the wrong computer putting this on.
I know, that's all right. It's okay. We're nearly there, I'm sure. So nice weather, eh?
I can't unmute.
Huh?
Oh, I did unmute.
Yeah, you're not. We can hear you.
Good.
Good God, oh Connor, that's quite something.
It's my internet.
Well, that is your internet. Okay. Well, I'm surprised we can hear you at all. Oh, here we go. Or at least partly the way there. Transferring data from Google. That's good. Yeah, I'm very surprised we can hear you, Connor. Like that's unreal. But I suppose, yeah, here we go. Thank God. Jesus Christ. Okay, thank God. Right, there we go. What is my IP? Now, I know it's obvious, Connor. Why don't you read that out to us? What's your IP address there?
89, 19, 67, 81.
Okay. Now, a very simple question. Does that match what IP address you had on your Windows terminal a few minutes ago?
No.
No.
I think I know the answer to the question you're going to ask.
Yeah. So they're not the same. Does anybody? This is probably an advanced question, but I'm open to discussion here. Does anybody have any idea? So Connor's laptop, or Connor's command prompt there, it says his IP address is 192.168.43.20, but on Google it says his IP address is 89.19.67.81. Does any Alex?
That is your public IP address, I'd assume. So
What very good, Alex. Well, yeah, and what do you think we mean here by public as opposed to what the Windows command prompt is showing, Connor?
like the command prompt IP is like your local network
Yes. Precisely.
IP.
Precisely.
Yeah.
It's his IP on his Wi-Fi network. Exactly, Alex, his local network. So if that's his local network, what device in Connor's whole network has the public IP address?
Uh
Think can I
don't know.
share for a second again, Connor, if I stop you there for a moment?
Yeah.
Cool. So if you stop sharing, you press the stop sharing button and I'll
Yeah.
start sharing. Yeah. Thank you, Connor. So
matter.
let's have a look at the diagram there, Alex. Right. So in that diagram, because it's right in front of you, what device in there has the public IP address? So if Connor's laptop has the Wi-Fi address, right? What is Connor's laptop talking to in this diagram?
To the router.
The router.
Okay.
Exactly. The router, which has the modem built into it, right? So that public IP address is the IP address of the router. That's public. It's facing the public internet. So there is no, I can't DDoS Connor's laptop with his 192 address. I also have a 192.168 address, there's only so many IP addresses to go around. So that's a very important distinction.
I have an actual question this time.
Sure, go ahead.
Isn't it the IPv4 address is the public one and IPv6 is the private one?
No. The V4 and the V6 is a completely different thing. So at the moment, Connor's laptop has an IPv4 address on his Wi-Fi network, but his router also has an IPv4 address. And the reason I know that, of course, is because the 192.168.x.y format is a 32 bits IP address, as is his 89. Whatever it was public address, and an IPv6 address is 64 bits. Am I right there, computer science people? Thomas, Caleb, Alan, people. IPv6 is at 64 bit.
128 bits apparently.
128 bits. Okay.
Yeah, for V6.
Is it dreadful?
I think there's like a variation to how long they are, right? So
yeah.
that maybe it's 64 at a minimum.
Yes, it could be something like that. Yeah. Well, but if you look at the diagram, oh no, that's not what I got. See that guys? That's an IPv version 4 address, right? Four sets of 8-bit numbers. That's what Connor's public and his private address was, right? Whereas with the IPv6 address, oh yeah, there it's just very simple. It's 128 bits. So yeah.
So 16 sets of bytes.
Yes. Okay. Very interesting. I didn't intend to get into that, but it's a good point to bring up, Kyle. The internet is trying to transition to using version 6 of IP, but there's very low uptake on it at the moment. So it's my Virgin Media router has a public-facing IPv6 address as it happens, but I actually disabled it and I told them to put it back to a IPv4 32 address.
You're slowing progress, Michael.
I know, it's terrible. But you can't have port forwarding on the Virgin router if you're using IPv6.
Yeah, that's their fault.
Yeah, they're dreadful. Anyway. Very good. So the IP address you have, we'll go back to the diagram. The IP address you have is specific to the network that you're on. So Connor's laptop is on his Wi-Fi network, but his router is on the public internet, right? So there we go. Now, so that's a bit about IP. Now, I'm now looking, thank you, Connor. I'm now looking for someone else to share their Windows screen. Have you any volunteers?
I would, but I feel if I do anything else on this computer, it might actually blow up.
You're probably better off, Kyle, I think, yeah. Anyone willing to share their Windows screen with the call?
I will.
I'm on, of course. Who's that?
I will. Get in.
Oh, Killian. Hello, Killian. Very good. Okay. Do you want to? Are you happy to share your Windows screen, Killian, with the call? Yeah.
Yeah.
Okay. Cool. Do you want to share your screen, Sophie? Oh, let me stop sharing, and you can press the share button down at the bottom.
My Windows is listing an uptime of 15 days. I turned it on like as in startup this morning.
Oh, that's weird. Okay. Oh, Killian, you have my VSync invite. Brilliant. I love it. Okay. Killian, do you?
We don't need to
do you
also
want
find
to-
that.
You go on to Google Chrome there for us, or whatever your favorite web browser is, as long as you don't say Edge. Okay, very good. Okay, so what we just learned, everybody, is that all devices connected to a network have an IP address. So let's interrogate that a bit more. Killian, why don't you? And I hate to bring it up. Why don't you go to the Coder Dojo website? If you go to coderdojo.com there, or whatever it is. Or actually, yeah, fair enough. Go to coder.com, yeah, why not? Okay, very good. Okay, so we're here on coderdojo.com. Thanks, Killian. Okay, let's keep that up now for a moment. So, Killian, by typing the address into Chrome there, has made a request. He's requested to pull down. You'll remember your HTML sessions, of course, at our dojo and Kinsale Dojo.
I shall never forget.
I'm sure you won't. So you all made HTML web pages, and what we've done now is we've just requested the HTML web page of coderdojo.com. Now, question is this: when Killian typed in coderdojo.com up there, how did the computer know? How did Killian's computer know where to send the request to fetch the Coder Dojo homepage? What server does it need to go to? How does it work that out? Is there some big mapping of names that tell the web where it should go to find the web pages associated with names of websites like coderdojo.com? So keep the page up there, Killian, right? I'm going to pose that question to everyone else. Does anybody have any idea what's used in the internet to find the location of a web page based on a name like coderdojo.com or IBM.com or whatever? Any thoughts? Can I ask our helpers like Alan and Caleb and Thomas, is this very painful for you? Because you probably know the answer to this and you're like itching to shout it out.
It's not painful.
Good.
Not too bad.
Good. Okay. Okay. Nobody? Anyone? Any thoughts? No? Okay. This is good. Right. Now, I've never tried. Killian, can I ask a question, Killian? When you were doing the operating systems class, did you have the Linux subsystem running, or what were you using? Git or the Git Bash terminal, or what were you doing?
I was using Ubuntu.
Oh, cool. I don't suppose you have the Ubuntu there.
Yeah, I think I do.
Oh, Oh, Thomas. No, it's okay. It's okay, Killian. Thomas has just sent me. Thomas, you're great. Thomas is private messaging me there, and he knows exactly what I want to do. Okay, so and he's telling me this will work on Windows. Okay, thanks, Thomas. So will you go? So Killian, will you open your you know your command prompt there, your terminal window? Okay, just like Connor did. Right. Oh, cool. Very good. I like to see people following along, Killian. This is great. Okay, so your IP address is 192.168.137. Okay. Now, I want you to type a command for us, Killian, okay? I want you to type ns, oh, this one word, okay? ns lookup, LOOKUP, ns lookup. Now, do space, type, yeah, and now put in coderdojo.com. And press enter on your keyboard. There we go. So what are we seeing down at the bottom there? So what we're getting, and we're not going to go through all this. We're here all day, okay? we're getting, and you see the very first thing under Killian's command there is a DNS request timeout, okay? What I want now, you can see there what we have, Killian, is something called. You see, it says non-authoritative answer, right? And then what you have under that, if you look at the bottom two lines, you've got two IP addresses there: 172.67.204.157 and 104.21.85.105. Now, what's interesting about those things is that what that is doing is it's telling us what is the IP address of the coderdojo.com web server. So when Killian typed coderdojo.com into his web browser had to talk to something to find out what IP address. Well, actually, it's the operating system that does this, not the browser. But it had to find out what website or what IP, what is the IP address of the coderdojo.com server. Okay, and Connor, question.
Never mind.
Okay. that was a bit anticlimactic. Okay. And correct me if I'm wrong, guys, but underneath Killian's addresses output, he's got two very long addresses. Are they IPv6 addresses?
I think so.
Yeah, I think so. Yeah, so there you go. So you can see how we knew. See how
The MAC address.
Huh? Go ahead, Connor.
It up to the MAC address.
No,
Up to the MAC address.
no, that's
Look.
no, it's not his MAC address. No.
No.
That's not his MAC address. Again, correct me if I'm wrong, guys. I don't think you couldn't, like, the MAC address is a specific address that's on the network adapter. You wouldn't be able to find the MAC address of coderdojo.com server from your, you might be able to find your MAC address and the MAC address of other computers on your network, but not remote servers, I think.
Yeah.
I guess I see why you think it's a MAC address, but actually, look, you can see the MAC address. Can we? Oh, on Linux you'd see the MAC address.
No, that's not an address. I just checked.
Huh?
That's not a
Okay.
MAC address.
Yeah, no, it's
That's
not. I'm pretty sure that's IPv6 address. You can see it's a longer number, right? Okay, so we have the IP address of the coderdojo.com servers, and now actually, Killian, do you want to stop sharing for a minute, and I'm going to share, okay? Just out of interest, I'm going to do the same thing Killian just did, and we'll see do I get a different answer. Share screen. This one. Okay, here. Right, so what I want to do is if I do ns lookup on coderdojo.com, and you're right, Thomas, it was a dreadful example. Oh yeah, well there you go. Interesting on Mac, I'm only guessing the I'm not getting the IPv6 addresses, but you can see there I'm getting the same two addresses as Killian, right? So let's try this. I'm not even sure how this works, but let's try. Let's take that IP address. I'll take the 104 one, and I'm going to drag this over here for a second. And I'm going to put that, I'm going to do https:// I'm going to paste that IP address in there. Oh, it won't let me connect to that. Oh, okay. That's not going to work. Okay, that certainly wouldn't work. Yeah. Okay. If that right, you can actually see there we're actually getting. We'll talk about a bit more about this in our security session, which is upcoming. But it's getting me. It doesn't. The CoderDojo website doesn't like the fact that I'm trying to get to it directly via its IP address. But I would be able to connect to some websites just using the IP address of the name. So this is the IP address of coderdojo.com, and for a lot of websites, I will be able to connect to them with just the IP address like that. So this translation. So I asked you all at the start, what was this thing? And it doesn't say on my output here, but you'll remember it said on Killian's output. It's a DNS answer, and that stands for Domain Name System. And I probably have something about that in my slides from before, just to show you a quick glimpse. It will save me Googling for it. DNS. So when I try and look up the address of a website, I have to talk to a DNS server somewhere on the internet to find out what is the IP address of the server I'm trying to talk to. So if that lookup is not working, you will not be able to talk to the website using its name, coderdojo.com. So often happens actually on the Aircom ISP or on the Vodafone internet service provider that their own DNS server goes down. So you can see there actually, you were asking about it earlier, Thomas, in the chat to me. It's saying that my DNS server, this is the server that my computer is talking to find the address of coderdojo.com. It's 89.109.160.5. I bet that's probably my internet service provider is Virgin Media, and it's probably using that to find out what's the IP address of coderdojo.com. So if Virgin Media's DNS server went down, it wouldn't be able to translate coderdojo.com into the IP address. And unless I knew the IP address here, I'd have no way of getting to coderdojo.com. So DNS is very, very important. Okay. Right. Thank you, Killian. Okay, let's move on a bit. So again, what I'd like to do now is I'm wondering, is there anyone else out there who would like to share their Windows laptop for us on the screen and do some tasks for us? That's right, Thomas, by the way. Yeah. Anyone? No one wants to share their screen? Okay. So, Alex, do you want to try sharing?
Sure.
Cool. Okay. You're happy to share anyway, Alex, are you?
Yeah.
Okay, cool. So if you just share your screen and bring up your web browser, Alex, whatever web browser you prefer. So you'll see the share button down at the bottom of the WebEx window. Perfect. Thank you, Alex. Okay. Now, Alex, just let's go to a different website this time. Let's go to IBM.com. just because I work here. Okay. Right. And it's it looks like it's taken us to IBM in Bulgaria, which is probably based. That's a very interesting thing that I didn't even anticipate we'd see this evening. So, do you have Alex? Do you have your web browser set by default to load pages using the Bulgarian language?
I thought BG was Belgium.
Well, look at the title of the page.
Oh, oops. I'm very, very blind.
No, are you in Bulgaria at the moment, Alex? Oh, you're muted, Alex. Remember to unmute yourself so we can hear you.
Yes, I am, and I just realized how to unmute.
Oh, very good.
Sharing. Yes.
Right. Very good. Oh, this is cool. So, okay, so it's not based on the language settings in your browser. It's because you're in Bulgaria. It's directed you. IBM has directed you to the Bulgarian homepage. Okay.
So,
Nice.
yeah, I'm on my holidays, so
Am I the only one that's
Welcome.
on holiday? Okay.
I gotta be honest, I'm honestly still not seeing the Bulgaria.
Do you not see
no
where?
mind, I
Yeah,
see
me
it there.
neither,
Just
to
as
be
I say
honest.
that, I see it.
Okay.
Just as I say it, I see it.
Cool.
Oh yeah, up there. Yeah,
Excellent.
yeah. Is
Yeah.
it? Yeah.
No, I thought that was Belgium. I actually had to look at the actual title of the
Belgium,
page.
I suspect Belgium would be BE for Belgium.
Yeah.
Yeah. Yeah, probably, yeah. Like the number plates. Anyway.
I cannot read Bulgarian, so English.
Well, it's probably you see, Alex, it's probably giving us English, as you said, because you haven't set your web browser to Bulgarian language. So
Thank God, like.
even though
to be
based
fair.
on your location is taking you to the Bulgarian website, it'll render the page in English.
Mm-hmm.
BGEN as well.
Yeah. Fair play to you both, Kyle and Alex, for coming on your holidays. I'm delighted. I hope you're not, if you want to drop off and enjoy your holidays, that's no problem.
It's like 10 o'clock. I guarantee you I wouldn't really be doing anything.
Okay. Right, so,
Fair.
Alex,
That's
here we are. Now, Alex, what I want you to do is I want you to look at your, can you read out, Alex, the entire contents of your address bar?
HTTPS www.ibm.com/bg-en.
Perfect. Okay. Now, what we're interested in is the very first. Feel free to contact IBM, Alice, if you do want some business transformation consulting. Now, what we're interested in here is the first part of that address, HTTPS. Now, again, a question to everybody except Alex, because Alex, you're sharing. Thank you, Alex. What I'd like to know is, does anybody know? And I would love if somebody knew this, because a lot of you love doing HTML at the dojo with our mentors. Does anybody know what HTTPS is, or HTTP? Hands up. Oh my goodness. If Coder Dojo wasn't over, we'd have to have a chat with our HTML mentors. Oh, there's no like those of you play games and things online, like no. Oh, Connor.
Is it Hypertext Transfer Protocol?
That's HTML, Connor. Well, fair play to you for
I
remembering
had
that.
HTML and my brain went mental. Yeah, sorry.
Yeah. What did you say it was, Connor?
Hypertext Transfer Protocol, and then the S is for security.
It was HTML's hypertext markup language. HTML.
Oh, it's HTML.
Yeah, but that's not what that says now. That says HTTPS. Right? At the start.
But he
Okay.
was saying it right,
He's
for the-
right,
apart from the S.
What's that, Caleb?
He was saying HTTP
Was,
standing
yeah.
for.
Right, okay. So HTTPS stands. Oh yeah, so you were kind of half there in a sense, Connor. Yeah, it's hypertext transfer protocol. There is that word again, protocol. So what we saw another protocol earlier. We saw IP. That is a protocol, the internet protocol that gives your computer an IP address. But we have another one here, HTTPS. HTTPS or HTTP or there's HTTP, Hypertext Transfer Protocol, and then there's HTTPS, which is Hypertext Transfer Protocol Secure. It's the secure version of the HTTP protocol. And guys, so the combination of, say, HTML web pages, like what you've done at the dojo, and HTTP, the protocol, these things together make up the World Wide Web. So what Alex is showing us right now here on his web browser, he's using the World Wide Web. The World Wide Web is an application of the internet. They're not the same thing. Remember, the internet is a series of computers that are networked together. But the internet, sorry, that's what I mean. The internet is a series of computers that are linked together. But the World Wide Web is an application of the internet. It's something you can use the internet for, right? That, my friends, is where www comes from. That's the next part of the address on Alex's address bar there. www. I was thinking about this earlier. I mean, we've some younger coders with us. I mean, back when the web was first a thing, back in the 90s, which most of you don't remember, I guess. Oh dear. back in the 90s, if you gave someone the address to a website, it always started with www. So google.com back in the day was www.google.com, right? The www, you probably knew it already, stands for World Wide Web. World Wide Web is the application of the internet that allows us to transfer web pages and other data from one another. But now, so that's the World Wide Web. Now, so we now know that www is the World Wide Web. It's an application of the internet. IBM.com is the name of the server where the IBM web pages, the HTML pages, are located. Now, I want to focus in back on HTTPS, right? So as I said, there's that word again, protocol, hypertext transfer, hypertext transfer protocol. Okay. I have a question for someone. What time is it? Hands up. What time is it? It's not a trick question. I think Connor got there first.
It's 1 minute to 9.
Very good. Okay, that's interesting. Okay, cool. And Ian, you've your hand up as well. Let me ask you another question, Ian. What day is it tomorrow, Ian?
Thursday.
Okay, you're probably wondering, has Michael lost his marbles? Okay, these things in our English language are examples of protocols. I asked Connor a question. I said, what time is it? And Connor told me the time, right? That is a protocol. It's something we both mutually understand together, okay? So when I say to Connor, what time is it? Connor knows probably to look at his watch or to look at his computer clock and reply to me with the time. We both understand that. I asked Ian what day is it tomorrow. He might have looked at his calendar and saw that today is Wednesday and therefore tomorrow is Thursday and replied that it's Thursday because Ian understands how to respond to that request. Connor understood how to respond to the question about what time is it, right? If I was to ask them to do something that they don't know how to do, that wouldn't be a protocol. It wouldn't be something to understand. Like if I was to say to Alex, who's sharing a screen, I don't know, Alex, would you put your computer into the clouds and let it float for a while? You'd probably be like, what? That's not a protocol. Alex doesn't understand how to do that, right? So a protocol is a format of communication that we both understand. If I talk to somebody in a protocol they don't understand, we cannot talk at all. We cannot exchange messages or data, okay? But if I talk to somebody with a protocol that they do understand, then we can converse, okay? That's what HTTPS is. Your web browser. Let's think back to the dojo now and all the websites you did. HTTPS is a protocol. Your web browser knows how to use the HTTPS protocol. When Alex typed in IBM.com into his web browser, he sent a HTTP message or a request to the IBM.com server. The server knows the HTTPS protocol. It knows that when it receives a request for a web page, that it should send that web page back to the user, which is exactly what happened here. Alex's Firefox web browser received back the HTML, again, the HTML you're all familiar with from the dojo, right? It received back the HTML as part of the response, as part of the protocol, and his web browser knows how to display that HTML on the screen to show the IBM pictures and messages and whatnot. That's how a protocol comes together, right? So, for example, Alex, you're still sharing. Why don't you change one of the characters in HTTPS to something else and hit enter? Pick a character in HTTPS and just change it or remove a character or something. Don't change the S one because it'll understand the non-secure version of HTTP. So if you change either the H or the T or the T or the P to something else, or remove one or something. Okay, cool. Now, you see what happened there? The web browser actually changed what Alex put in and put it back to HTTPS. The web browser doesn't understand how to do anything except issue a HTTPS request, okay? But that is the protocol that we're using to retrieve the web page, okay? Okay, thank you, Alex. You want to stop sharing? That's very helpful to us. Okay, now, so we send a HTTP request to the server and we get a response. Now, I'm going to share for a few minutes before we go back to all of you, okay? I'll share this screen here. Now, you all know, because we just saw it on Alex's computer, and you all did it at Coder Dojo when you made your HTML websites in the HTML class, that if you open your HTML page in your web browser, or you request a page from a server like IBM.com or CoderDojo.com, your web browser is going to fetch the HTML of that page and display it on your screen. But did you know, and you can do this at home as well. I'm not sure will this work on the Windows terminal out of the box, so I suspect it won't. But you can fetch a web page using your command line as well. And this is the one thing I wish I'd been taught in college as a computer science student that I never learned, and that is something called curl. Curl is a utility that will allow me to fetch resources from the internet using a protocol like HTTPS. So I can do something like this, just as if I was accessing the web page in my browser. Again, you might as well try this at home. You should probably, if you have the Linux terminal or the Linux subsystem, Git Bash, it would be better if you tried this and that. I don't think Windows out of the box is going to do a curl. But if I do this, I get a, look at that, guys. I get a HTML response, just like the HTML you typed in the HTML class. Okay, there's the HTML, there's the head section, there's a title, and we have a body, a header moved permanently, paragraph. The document has been moved to a href. That's a link to another web page. Okay, so that's the actual HTML of the web page. But this isn't what we expected, though. This isn't the Coder Dojo web page, is it? No, it's not. It says 301. That's a response from the server that tells us that the web page has been moved to here, right? So that what we can do is if I put a -L in here, like that, a capital L, and I do that, it will follow the move. So wherever it's been moved to, it will follow that. There we go. Look at that, guys. There is the HTML and some embedded CSS and some JavaScript from the Coder Dojo homepage. There's the body. Thank you for your interest in Coder Dojo. The coronavirus pandemic continues to impact all our lives. Blah, blah, blah. So if I go www.coderdojo.com, there is the text. So your browser understands how to render HTML into the nice layout. But with curl, I'm just getting back the raw HTML and CSS and JavaScript and whatever else of the web page. Okay? We use curl all the time at work, believe it or not. Not to fetch web pages. You wouldn't really fetch. You can fetch web pages with curl. It can be a useful debugging tool, but you wouldn't really fetch HTML web pages with curl. We'd fetch other resources with curl, which is what we're going to move on to now and look at some code. Does anybody have any questions about this now before we move on? I want people to understand again that what we're looking at here is the HTTPS protocol, Hypertext Transfer Protocol, that allows our web browser to fetch HTML data from the CoderDojo.com server. And we can use the curl utility, to make those requests as well. Okay? We're making a HTTP request to CoderDojo.com and we're getting a HTTP response. Any thoughts or anything or comments? cool. I hope that means I've explained it very well, or you're totally impressed by everything you're seeing. Okay, that's cool. Right. So there's a bit about curl. So all of this corresponds to something we call client-server architecture. And I am going to show a diagram on that. The entire web, for the most part, with HTTP is based on client-server architecture. If I can find the bloody diagram beneath my windows here in WebEx. Surely I put this in here somewhere. There we go. So this is what this. Let me just move this out of the way. So this is what's happening every time you use the web. Client server. Your client, which is your desktop or your laptop or your iPhone or your tablet or whatever, when you access coderdojo.com or IBM.com, you are a client. You are a client and you're making requests to a server which is always on, or at least it should be always on. A web browser running on a client like your laptop requests a web page from a server, which responds by sending back the web page to a client. So there's my computer. If I zoom in on that diagram there, look. There's my computer. And I send a request if I want to, if this is the coderdojo.com server here down in the corner, my request has to go out at my modem to my ISP, which has to be routed through the global internet and eventually find its way to the coderdojo.com server. And the coderdojo.com server will send back the HTML page back across the network to my computer. That's what we call client-server architecture. All of you here tonight are using it every single day. Every time you look at a web page, that's client-server architecture. Your laptop is the client, and the server is off somewhere in a data center or the cloud or whatever. Which brings us nicely to how I want to finish up tonight, I hope, right? We have 20 minutes left, so, and like I said, I still want to try see if we get you to do some coding. So, we can program, we can write Python programs and whatnot to talk to servers, okay? Servers don't just have to return HTML, they can return lots of other different kinds of data as well. And what I've done is I've built a sample application, basically like a user's database application. And you can all access it right now, and I hope you do, right? I'm gonna actually get someone else to share in a moment. But for someone else to share, I need someone who can run a curl command, just like I did here, okay? If not, maybe what we'll do is we'll get one of our mentors to do it, just so that I'm not doing all of it, okay? Now, right, so you see this IP address up here, everybody, in my web browser. See, I'm using an IP address, not the name, not a name. This is where my app is running. It's a JavaScript-based application written in a framework called Node.js. It's running on this server, which is an IBM cloud server in IBM's data centers. It's running on a particular port, 32141, and it's listening at this path here, /users. I'll put that into the chat right now in WebEx, and you can all try and go to it in your web browser. If you click on that, you should be able to go to it, right? And yours might appear a bit differently depending on what browser you're doing. See that it's essentially blank. If I press raw data here, the only content I'm getting back are these two empty brackets. Okay. So my web browser is issuing a request to this server, and it's getting back an empty, like an empty list. That's what this is. Okay. What this should be is a list of users who are in my database. The fact that it's empty means that there's nobody there. There's nobody in the database at the moment. I can also curl this. Actually, maybe I won't do this. Maybe I'll get someone else to do it. Is there anybody out there, right, who knows that they can run a curl, who maybe did it when I was doing it there, who knows they can run a curl command and would like to try this for me and share their screen? Nobody?
I can if no one else can.
Absolutely, I can come to you, Caleb. as well.
I just tried and got a reply.
You got what?
I got like something back.
Do you want to? Cool. That might mean it'll work for you. So okay, Connor, I see you have your hand up, so you can do the next one. So maybe Ian will start with you. Do you want to share? Can you share your screen, Ian?
Yeah, 1 second.
Okay. Oh, cool. So you can. So you're actually doing it in the Windows command prompt.
Yep.
Oh, very good. Okay. So you got a hello world response. I left that in there as a bit of as a surprise. Okay. Now, what I want you to do though, Ian, just I'm gonna you type this out, right? And the next one I'll send to Connor because it's a bit more involved. Okay. What I want you to do, Ian, I want you to type out curl, the same thing you have above, curl 169 blah blah blah. If you do all that and space. Now, what I want you to do, Ian, I want you to put a minus symbol, and I want you to put a capital H. Actually, sorry, Ian, I've actually made a mistake. Can you delete those? I beg your pardon. Sorry, delete those. Can you put a / users after the port number there, after the one? No space.
Oh wait, yeah.
Yeah. It was the same thing I did in my browser. Is it users? Sorry, is it users or it is users? Okay. Now space, and now do the minus H, Ian. So space minus H, capital H, and then do another space. And I want you to put like an apostrophe. Like yeah, exactly. I want you to type out. I want you to type accept, ACCEPT, and we'll get rid of the space there. Come back, get rid of the space. And now I want you to do a colon. You know, 2 dots, Ian, if you right, 2 dot, yeah, and do a space. And I want you to type application / JSON. Or also JSON.
Oh wait,
JSON. Okay, and now put a closing comma or apostrophe. Sorry, apostrophe. Ian. So what we're saying here is when we talk to the server, what we want to get back is what we call a JSON response. JSON in our business is JSON. It stands for JavaScript Object Notation. It's just a format of data. Do you want to press enter there? So, Ian, and look at that, Ian. You got back the two. You got back the 2 empty brackets. You see that?
Yeah.
Okay, cool. Why did you say that? Could not resolve holes. Maybe this is a Windows thing. Maybe it's not. Maybe it's not reading the header, interpreting the header the way I thought it would in Windows.
Double quotes, maybe?
It should work with single quotes. Can you do that again, Ian? Let's try. If you press up on your keyboard, it should bring back the command.
I think it doesn't work in Windows.
Oh, there you go. Now, change it to double quotes. I don't think so. But, oh, well. Fair play to you, Caleb.
Nice.
That's on my Mac now. I could do it either way. Okay, cool.
Yeah, Windows being strange.
Yeah, very. Okay, so there you go. So yeah, we got an empty list. Okay. So you've just sent a curl request, Ian, to my wonderful app with users, but it has no users in it. It's an empty database, right? So we need to put someone into it. So will we go to Connor, because Connor, you had your hand up as well, and Ian, we know you can run this. We might come back to you, Ian, if Connor has a problem. Are you willing to try this, Connor?
Yeah, no, my issue last time was my antivirus didn't scan and I didn't notice.
Oh, okay.
Yeah,
Okay.
so it was using up like my entire days.
Fair enough. Okay. Do you want to try sharing your screen? So
yeah.
There's a bit more typing in this one. In fact, there's so much so that I'm going to give you some of it, right? Let me see now. When I did it earlier, where did I do it? Here we go. I'm going to put some of it in here for you, okay? But where's the virus window? Okay, so can you go to your command line, Connor? And say that again, Connor.
Do you want to one or?
Yeah, do you want to one? Yeah, that'd be great.
Okay.
And can you run? It's very blurry. Can you run curl commands, Connor?
Yeah, I got it.
Okay, okay. Your screen is very blurry at the moment, so we can't make out the text clearly. Oh, there we go. Now it's working. Okay. Just come to a new line, Connor. If you just hit enter.
There.
Okay. Right. So what I want you to do is I want you to type in the same thing Ian did. Okay. So you want to type in curl, CURL.
Mhm.
We're actually not
I
seeing.
didn't delay the thing, which is why it's looking like it's taking a while.
Yeah. No, actually, your screen isn't updating at all for us, Connor. We can't see you typing.
Okay.
You're still back on the original Connor line after you obviously curl something before. No, it's not okay. Would you mind if we go back to Ian, Connor, just for the sake of time?
Yeah,
You
that's
can do this anyway, right? I hope you both all do this, okay? So are you happy to try this, Ian? Sorry.
Yeah, no problem.
Okay, cool. So if you have curl, yeah, so Connor, please do this right when I put it out, right? So if you share again, Ian, right? Let's get a new laptop for Christmas, Connor. Okay, so
Now my Wi-Fi, it's my Wi-Fi, I think.
oh really? Okay. Oh, probably
Yeah, I'm running off a hotspot right now because my Wi-Fi
that explains it.
isn't
Okay.
really working.
Yeah. Okay. So Ian, what I want you to do is I want you to bring back everything you or no, actually we'll start from scratch. I want you to again write curl 169 dot blah blah blah, just like you did, right? just as above. Okay, now if there's a few stop there now a second. Stop. we for this one now we don't need the accept thing, Connor. So delete this. Okay, we're gonna do something else instead. What I want you to do, Connor, is I want you to change the -h to a -x.
That's Ian.
There we go. Now, Ian, do a space, and I want you to write down put, P-U-T, in capital letters. I don't think it makes a difference, but let's put it in capital letters. Put. And now I want you to do space, -h, and this time you're going to do a double quotation mark again, like above, and you're going to write out content hyphen, a hyphen, you know, like a minus sign. Yeah, a type T-Y-P-E, T-Y-P-E. Exactly, content type, and then do a colon just like you did after the accept. And I want you now the same thing as above, Ian, application/JSON. Okay, now the next thing I want you to do is do space and -D. This is why we have web browsers, guys. Isn't this a lot more involved than doing things in your web browser? But you'll see why we're doing it like this way shortly. Now, I think this needs to be a lowercase d now, Ian, right? So if you change that to small d, right? And now I'm going to send you what to put in next in the chat window. Everybody will see it in WebEx. I've sent the -D as well. You can ignore that. Just take everything I have after -D. And what I want you all to do, if you're doing it, I want you to change the ID to a different number. You see, I've got a number 1. I want you to change it to something else. And I want you to change the username to maybe your own name, your own first name.
Should I change these to
No, they're fine. No, put those back on, Ian. There's a reason for that. Put those back. This should be okay, I hope. So we want single ones around it, but we want the double ones in the middle, right? So put in your name, Isin, and put in a different. Oh no, leave username there. Leave the word username there, and change the ID some other number. Don't just go 2 or something. Pick another number. Okay, cool. Now try running that, Ian. Hopefully we won't have any Windows complications here. Ah, damn it. My bad coding. Unmatched calls brace. I wonder, is it the way that Windows is interpreting that command? You're about to say something, Caleb. I always hear a noise when you're about to speak.
No, I'm just looking at. I guess you had me on mute.
I heard you unmute. Yeah. Like you could probably change it all to double quotes, but you'd have to escape the quotes in. Or maybe we could do
Oh
that.
yeah,
Ian,
double quotes.
Yeah, Ian, can you change the single quotes on either side of the string to be double quotes and try changing the double quotes inside the object to single ones. So everywhere you see a double quote, put a single quote, and everywhere you see a single quote, put a double quote. This seems to work.
This is why hardly anyone at IBM uses Windows for development.
Say that again, Caleb.
This is why hardly anyone at IBM uses Windows for
Well,
development.
the German woman, the STSM I was talking to was using Windows, but we won't get into that.
Yeah.
Didn't work.
Why is it saying rough is not recognized as a command?
Oh, there's no curl.
Look what you've got at the start, Ian. You've got C users rough, C users rough. So just copy from the curl. You see, start with the curl. You copy. Don't copy. Go up a line. See where you've got your curl starting with the C.
Yeah.
Just copy from there, right?
Here.
Yeah, you'll need to put curl before you paste that in. Now you'll need to type curl into the window, right? Let me just open my windows here for everyone.
You know.
Anyone else trying the curl command, just make sure you actually have the word curl at the start of what microperson.
Okay, try that, Ian.
Yep.
No, it's not liking it. Okay, let me. Ian, can you paste that command into the chat for me? The command you're running. Let me try something really quickly, and I'll send it back to you to run. I'll try escaping it, Caleb, and we'll see if that'll work.
Oh yeah.
Goodness me, Windows.
Should I stop sharing or?
No, stay there. I'm going to send you this back, and then you try it, right? I'm just gonna, for time's sake, I'm gonna do this quickly. Here, put -D, so we want. Caleb, can I escape? I probably should have asked this, but can I escape characters on Windows with the backslash?
I hope so.
So do I. Oh dear. Ian's gonna find out for us. Okay, Ian, I'm gonna put this back into the chat now. You'll all see it. This is what I want you to try now, Ian. Right? You copy exactly what I've done there and just put it into your paste that into your terminal and see if you can run it. Oh, cool, it's working. But I've made a mistake though. Oh, I beg your pardon. Can you change the users to user? Take out the S in users. That was my mistake. I made that. That was an accident.
Here, right?
Yes. Now run it. Hooray! It works. So it appears that Windows command line doesn't like single quotes at all. So you'll notice, guys, that I put backslashes in front of the double quotes in the middle. And the reason we had to do that is because we're using double quotes on the outside. So we need to use when we want to use the double quotes on the inside, we need to escape them. That's what it calls. We use the slashes. So now what response did you get, Ian?
Gotta put request at /user.
Cool.
And,
now
in Chrome.
Cool. Now, Ian, take the curl command, the original curl command up at the top of your window with the /users and run it again. Exactly. If you run that again, make sure you put curl at the start. Now run that. Well done, Luca O'Shaughnessy. Well done, Luca, the other person who's got it in. So we can see there that we're now, Connor.
I'm trying to do this. It's giving me like a blank line when I press enter.
That's normal. It'll give you a blank line when you return. That's my bad coding.
Okay.
If you just press enter, Connor, it'll move on to the next line.
Okay.
So what have we got now? We've now got some users in our database, right? We've got 2 users. We've got Ian and we've got Luca. two different users with the two different IDs. So what have we done here, guys? We've done two things. What Ian has just done is he's issued a HTTP GET request. The default HTTP action is called a GET request. We're getting data. We're fetching data from the server, right? Every time, if you open your web browser there for a second, Ian.
Yep. Now 1 second, I'll start sharing it instead.
Okay. Actually, don't bother, Ian. I'd rather you keep up the terminal. That's all right. It's okay. So whenever you go to your web browser and you type in www.ibm.com or coderdojo.com or whatever, what your browser is doing is sending a HTTP GET request to get the web page. You're receiving data from the server. But HTTP supports other actions, okay? HTTP can send data to a server. That's not something you can do in your web browser in your address bar. And both Ian and Luca have done it here. You can see in Ian's second curl where he sent some data to the server, he put in a -x put. That's a HTTP put request. That's when you, the client, wants to send data to the server. So Ian and Luca have both sent over their user details to the server, and they're now stored in the database. So both Ian and Luca sent HTTP put requests, and there's lots of other HTTP kind of requests as well. Like
Yeah, actually, well done for getting that right, because I was trying to do it too, and I was using a post accidentally, so that's why you can't see my name now. So well done, Ian and Luca.
Yeah, absolutely. Post is another one. Isn't it right, Kaylin? We normally use put to create data on the server, and we use post to update data on the server. Does that sound? Depends on who you ask.
It's the other way around, no?
Yeah, I thought it was the other way around, but it's all loosey goosey anyway.
Of course, yeah. It is, yeah. And it works on PowerShell. Okay, thanks, Thomas. That's good to know as well. Or you're checking if it will work on PowerShell. Okay, I think it should work on PowerShell. But there's other things as well, like post is another one, options is another one, delete is another one. I have a delete one as well for deleting data, but we're out of post won't work, Ian. If you change that, go ahead and run it, Ian, just for fun. if you run it. You see, it says there, cannot post /user. My Node.js application doesn't know how to handle HTTP post requests. If you stop sharing now for a moment, Ian, I'll show everybody what's actually happening up in the cloud. And before we finish up, we might do a bit more of this next week because I think it's a bit of fun. Maybe I'll save the Python coding for next week. Just this is good. I like this kind of stuff.
Yeah, this is fun.
It is fun. What was I going to do? Oh yeah, my Visual Studio Code. Let me take this out. This is the app, guys, up on the server. This is Node.js. It's JavaScript code, not Python. And you can see there, these JavaScript coding isn't the subject of this. These sessions, right? But basically, when Luca and Ian, or sorry, I should say, all of you who sent. Well, I should start down here. When Ian and Luca sent their data to the server, so it's not this, sorry, it's this one, I beg your pardon. When Ian and Luca sent their data to the server, they sent a HTTP put request to my server IP address /user. And then what you can see there is, there's the response, got a put request at /users, that's the response. And what I'm doing up here is I have a list of users, just like we've listed in Python and JavaScript, we've listed as well. So this is a list of users. And what we were doing is we're saying users.push request.body. And request.body, the body of the request was the data that Ian and Luca sent in the braces with the ID and the username. So it pushes that information into the users list. When you've all tried it, if you've all sent GET requests to /users, all it's doing is returning the users list, which is why we see both Luca and Ian in the list. Someone has their hand up. Who's Connor? You there, Connor?
up.
You might want to write your question, Connor, but your audio is breaking up very badly now, I'm afraid. So if you write your question, I will answer it. There's another thing as well. I have some other endpoints in here, like for deleting a user. I can also get the details of one user using their ID. I'll do that there just for quick sake. If I fetch Ian, your ID was 16, wasn't it? If I do oh sorry, that's not the window. Hang on. So I want to curl, or can I? Search for it. 1 second now, Connor. Let me just find this. So many bloody windows. I have it on my name. /user / where did I don't do that in this window. Oh, it must be in this one. Oh. See my busy day. Curling. Why can't I find that? Oh, never mind. I'll just do from scratch. Oh yeah, I can use this. So this one. So if I curl 169.51.203.121 port 32141 / users, and Ian, your ID was 16. So if I put /16, that corresponds to this guy here. I'm going to send a GET request to / users /16, where 16 is your user ID that you gave in. And I'm going to do it's a GET request, so I don't need that. And I want to say -h accept application JSON, or not like that. That's JSON. What am I missing there now? Oh, it's German. Oh, hang on. Sorry, I've not done the port properly.
It's meant to be user as well.
Oh, is it user? Yeah, I beg your pardon. That was my typo. No.
Oh, maybe.
Users.
What? Oh, users what worked for me. Oh, it is users.
Users, yeah.
Oh, users just for the okay.
Yeah, that was what I said. What's it say? Not found. Why not? User not found. If I list all the users again?
Is that because it worked before? Oh, it's there.
I don't know. Unless I have a bug in my app, but I tested earlier. Not like
The classic demo syndrome.
exactly, yeah, but this is the best way now. Oh. I must have messed something up. I bet it's like a string to integer conversion problem. Okay, don't worry. Yeah. I'll have that fixed for next week anyway, don't worry about it. You should be able to fetch individual users from the database with their ID. Like Luca's ID is Ace and whatnot, so that's funny. Yeah, funny. Okay. Anyway, so that's that. So that's the app. It's running up on my cloud. We might make some. Now, one thing I will say about it though, I'm going to do this to finish off. My application is running on something called a cluster, a Kubernetes cluster. And what I'm going to do is I'm going to delete it. That's the running Node.js app there. And I'm going to delete it. And my cluster will restart this application for me. Well, not restart, it will recreate it for me in a moment, right? And when we do, I want to list the users again. This is a preview of what's coming next. Maybe not next week, but we'll see. So yeah, guessing and putting information from the server via HTTPS. So your web browser in the HTTPS protocol does a lot more than just fetch web pages, right? What I'm also going to show you next week, I had them written to show you today. I said I was going to open the coding rooms and I was going to ask you to do it, but we'll do it next week instead. I have some Python code samples here that will send data to the server, just like Ian and Luca have done, and retrieve data from the server. So I'll show you how to interact with these things in Python code to build your own apps. So that'll be for next week. They're the things deleted now. Get my pop out. So that's running again now. created 53 seconds ago. If I now list the users again, I'm back to an empty list. The reason being is that this isn't a true database. If the application restarts, it restarts from scratch, loses all its data, the user's list is set to empty again. So if we want to persist, if we want to save our users so that they be still there, when I turn the app off and on again, we need a real database. And that is one of the topics of these sessions. So maybe next week, maybe the week after, we'll see how we're going. We'll start looking at MySQL databases to show you how we can, what they are, how they can be used to store data, and how they can be wired up to your app so that you can save data long term. All right, so that's all to come. And we'll also be exploring security in the context of this app as well, right? How to secure it and secure data and encryption and decryption and whatnot. But anyway, I think that's enough for tonight. Thank you all for sticking with me through the demo. I hope you enjoyed some of this stuff tonight. I thought it was pretty cool. Does anybody have any questions before we finish up about anything we've seen? Let me check the chat window. I know, Thomas, I was trying to do 4 different things this morning when I put this together at once. Connor, when I put in the code, I get we cannot put users as a result. I think you need to change that to /user, Connor, not users. That was my mistake. And Thomas, you're saying the PowerShell syntax for curl is worse than CMD. Okay. Okay, if there's no questions, I'll stop the recording and I'll give you an opportunity to ask questions off the recording. I'll make the recording available online, of course, on the YouTube channel. So stop recording.